Okay, we have 4 learning targets for today. We're going to know and use the special properties of a trapezoid and an isosceles trapezoid. We're going to know and use the properties that ensure that a quadrilateral is a trapezoid. Notice that it says quadrilateral, not parallelogram, because trapezoids aren't parallelograms. Okay? Know and use the trapezoid midsegment theorem. So, we're going to have to know what a trapezoid is, and then what a special type of a trapezoid called an isosceles trapezoid is. Then we're going to have to know a theorem about trapezoids. In fact, we'll have to learn what a midsegment of a trapezoid is. And then finally, know and use the special properties of a kite. So, we've got to learn definitions for trapezoid, isosceles trapezoid, midsegment of a trapezoid, and kite. Okay? So quite a bit of vocabulary here. So starting on page 435, a trapezoid is a quadrilateral with exactly one pair of parallel sides. Now it says exactly one, meaning it can't be two. Okay? Because they don't want to leave any room for you misunderstanding there, because you might say, oh, well, that means that a parallelogram is a trapezoid because it has 2 pairs of parallel sides, and if it has 2, that means it has 1. Nope, they don't want you thinking that way at all. Exactly 1 pair of parallel sides. So in a trapezoid, 1 pair of opposite sides is parallel, the other pair of opposite sides is not parallel. 1 pair parallel, 1 pair not parallel. Okay? The parallel sides are called bases. So in this drawing here, I'm showing you segment AB and segment CD are the bases of this trapezoid. The non-parallel sides are called legs. So segment BC and segment AC are the legs. Now, base angles we've talked about before when we had isosceles triangles. The base angles, isosceles triangles had 1 pair of base angles. Trapezoids have 2 different pairs of base angles. So the 2 angles that are formed by segment AB are 1 pair of base angles. And I don't really mean to say that they're congruent. So those 2 that I've marked in red are 1 pair of base angles. Then angle C and angle D are formed by segment CD, the other base. They make the other pair of base angles. Okay? So there's not a pair of base angles. There are 2 pairs of base angles. All right? Everybody with me? So we know what a trapezoid is. Now we need to know what an isosceles trapezoid is. If the legs of a trapezoid are congruent, then it is an isosceles trapezoid. And let me give you a hint here. The bases will never be congruent. In a trapezoid, the bases are never congruent. Okay? So, remember, trapezoids are not parallelograms. They do not have any of the properties of parallelograms. The only thing a trapezoid has in common with a parallelogram is that they're quadrilaterals. There are no other properties in common. Okay? So, here's our first theorem about isosceles trapezoids. If a trapezoid is isosceles, then each pair of base angles is congruent. I kind of like that because we're used to thinking of base angles as being congruent when we call something isosceles. In an isosceles triangle, base angles are congruent. In an isosceles trapezoid, each pair of base angles is congruent. Okay? So in the drawing they give us over here, angle G is congruent to angle H because that's 1 pair of base angles. Angle F is congruent to angle J because that's the other pair of base angles. Okay? Next theorem, If a trapezoid has one pair of congruent base angles, then it is an isosceles trapezoid. Oh, okay. They're already telling us how to ensure that we have, in this case, we're not even ensuring that we have a trapezoid. We're ensuring that we have an isosceles trapezoid. If we know it's a trapezoid, and we know that one of the pairs of base angles is congruent, that proves it's an isosceles trapezoid. Okay? Now, you might wonder why you don't have to know that both pairs of base angles are congruent. Here's why you don't have to know both. If these two are congruent, remember what a trapezoid is. Parallel lines. Transversal. So isn't angle L supplementary to angle K? Yeah. Isn't angle M, which is congruent to angle L, supplementary to angle P? Yeah. So remember the theorem we had that said if two angles are supplements of the same angle or of congruent angles, then those two angles are congruent? Angle K has got to be congruent to angle P, doesn't it? So when you know you have one pair of congruent base angles, you actually know that you have both pairs of congruent base angles. Okay? So all it takes to prove that a trapezoid is isosceles is knowing that one pair of base angles are congruent. And then this next theorem, they give us both a theorem and its converse in one statement. And I don't know why they're doing it here when they usually don't, but here we go. A trapezoid is isosceles if and only if its diagonals are congruent. That means if you know a trapezoid is isosceles, you conclude its diagonals are congruent. It also means if you know that the diagonals of a trapezoid are congruent, you conclude it's isosceles. Now you may feel like that this goes against something you've already learned. Because didn't we say something similar about rectangles? Rectangles are the only kind of parallelogram where the diagonals are congruent. See, this doesn't contradict that, does it? Because trapezoids are not parallelograms. Okay? So it's still true that the only kind of parallelogram where the diagonals are congruent is a rectangle. But trapezoids aren't parallelograms, so there's no contradiction. The only kind of trapezoid where the diagonals are congruent is an isosceles trapezoid. Questions? All right, let's do a few. So over on page 440, find each measure. So we need to find the measure of angle D. Well, look what we have here. We have one pair of parallel sides. And look, it is safe to assume this. If they tell us we have one pair of parallel sides, so they've marked something parallel, but then they don't mark the other pair of sides parallel, we can go ahead and say, okay, then they're not parallel. Now, they don't always tell us parallel, do they? But if they indicate some parallel, they're going to indicate all of the parallel, okay? So we've got one pair of parallel sides, so this is a trapezoid. The non-parallel sides are congruent, so this is an isosceles trapezoid. If it's an isosceles trapezoid, what do we know about each pair of base angles? They're congruent. So what's the measure of angle D? Yeah. Look at number 2. We're supposed to find the length of WT if ZX is 20, so that's this diagonal, and TY is 15. TY is this portion of the other diagonal. Now, what kind of trapezoid is this? Isosceles again. What do we know about the diagonals of an isosceles trapezoid? They're congruent. So if one diagonal has a length of 20, so does the other. If we know the length of that diagonal has to be 20, then what's the length of that missing piece? So the length of WT equals 5. All right, number 3. It says quadrilateral ABCD has vertices A, -4, -1, B, C, and D. Verify that ABCD is a trapezoid. What's the definition of a trapezoid? We only know one thing about just trapezoids. We know a couple of things about isosceles trapezoids. But what's the only thing we know about properties of a trapezoid? Yeah. We get one pair of parallel sides, not two. We don't get 0, we don't get 2, we get 1. Well, we can check for that with slopes, can't we? Let's just find the slope of every side, and we should get one pair of parallel sides. So here we go. Let's find the slope of segment AB. So that'd be 3 minus -1 over -2 minus -4. That'd be +4 over +2. We get 2. Then let's find the slope of segment BC. So that's going to be 3 minus 3 over 3 minus -2. That's 0 over 5. That's 0. So that segment's horizontal, isn't it? Then let's get the slope of segment CD. That'll be -1 minus 3 over 5 minus 3. So it'll be a -4 over 2, -2. And then last, the slope of, what have I not found yet? dA would be -1 minus -1 over 5 minus -4. So that's 0 over 9. That's 0. All right, so AB, CD is a trapezoid since which two sides are parallel? Segment BC is parallel to segment DA, but segment AB is not parallel to segment CD. So, exactly one pair of parallel sides. Determine whether ABCD is an isosceles trapezoid. Well, if it's isosceles, and there's a few different ways we can go about this, but the most straightforward way is the definition. If it's isosceles, the legs are congruent. Which two are the legs? AB and CD, because they're the non-parallel sides. So let's find the length of AB. Let's find the length of CD. If they're equal, then it's isosceles. If they're not, it's not. So the length of AB is going to be the square root of -2 minus -4 quantity squared plus 3 minus -1 quantity squared. So that'll be, let's see, what's that? 2 squared is 4. That'll be 4 squared is 16, so that's a square root of 20. Then let's find the length of CD. We'll get 5 minus 3 quantity squared plus -1 minus 3 quantity squared. So that'll be 2 squared is 4. That'll be -4 squared is 16. So that's also the square root of 20. So ABCD is an isosceles trapezoid since the legs are congruent. All right, how are we doing? Okay. So we've learned a lot about trapezoids and isosceles trapezoids. We've worked a few problems. But if you recall, there was another learning target about trapezoids, about the mid-segment of a trapezoid. So we need to know what a mid-segment is. This is on page 437. The mid-segment of a trapezoid is the segment that connects the midpoints of the legs of the trapezoid. A mid-segment connects the midpoints of the legs. A mid-segment connects the midpoint or the midpoints of the legs. Okay? Now, we have a trapezoid mid-segment theorem. The mid-segment of a trapezoid is parallel to each base. Okay, so the mid-segment's parallel to the bases. And its measure, its length, is 1/2 the sum of the lengths of the bases. 1/2 the sum of two numbers. Isn't that the average of two numbers? Okay? The length of the mid-segment is the mean of the lengths of the bases. The length of the mid-segment is the mean of the lengths of the bases. All right. Number 5. In the figure at the right, the length of YZ, I should say segment YZ, shouldn't they, is the mid-segment of trapezoid TWRV. In fact, it has the segment thing in the book. Determine the value of X. All right, now, the length of the mid-segment is found by taking 1/2 the sum of the lengths of the bases. So here's the equation. The length of the mid-segment is 1/2 the sum of the lengths of the bases. Follow me? The length of the mid-segment, 8, is 1/2. The sum, so I'll put parentheses with a plus sign there in the middle of it, the lengths of the bases. So then I filled in the lengths of the bases. And we could distribute that 1/2, but you know what's easier? See, what I think is easier is multiplying both sides by 2. Because if I multiply both sides by 2, look what happens. I get that. But what's 2 times 1/2? 1. So now I just have that. And I'm in pretty good shape now, aren't I? All right, so what's 16 minus 15.8? And that's X. That's all we had to find? Yep, determine the value of X. We're done. All right. Questions on the mid-segment theorem? All right, we never have talked about a kite yet. The definition. And the definition's kind of weird. A kite is a quadrilateral with exactly 2 pairs of consecutive congruent sides. And then we got to kind of keep going for this to really sink in and make sense. Unlike a parallelogram, the opposite sides of a kite are not congruent or parallel. So in a kite, the only thing it's got in common with the parallelogram is it's got 4 sides. Okay? There are no parallel sides. There are no congruent opposite sides. Let me rephrase that. No pair of opposite sides are parallel. No pair of opposite sides are congruent. Okay? So it's not a parallelogram at all. What it does have is two different pairs of consecutive sides are congruent. Okay? So these two consecutive sides are congruent. So that's one pair of consecutive sides congruent. And then these two consecutive sides are congruent. And shockingly, it looks like a kite. Okay? So kites are strange creatures. They really are. Then we have two theorems. If a quadrilateral is a kite, then its diagonals are perpendicular. Now, this does not contradict what we learned about a rhombus. A rhombus is the only kind of parallelogram where the diagonals are perpendicular. But this doesn't contradict that because this is not a parallelogram. So, if it's a kite, then its diagonals are perpendicular. Okay? And if a quadrilateral is a kite, then exactly one pair of opposite angles is congruent. Not both pairs of opposite angles congruent, just one pair. And look which pair it is. It's the pair between the non-congruent sides. Okay? See, it's this angle, which is formed by two sides that are not congruent to each other, congruent to this angle, which is formed by two sides that are not congruent to each other. Okay? So, the properties of a kite are kind of difficult to keep straight sometimes, just because there's no good, easy, simple sentence to tell you to make that. It's kind of complicated. Okay. All right. Let's see if we can use them though. If we can use them, we'll be in better shape. So number 6. If ABCD is a kite, find each measure. They want us to find the length of AB. I'll call it X, just to have something to call it. What do we know about the diagonals of a kite? Perpendicular. So doesn't that make this a right triangle? And we can use the Pythagorean theorem. In fact, this is a Pythagorean triple. 3, 4, 5. You can work it out with the Pythagorean theorem, but you'll get 5. That was easy. Maybe they're all going to be easy. Maybe. Could be. Measure of angle C. Is it or is it not 120? It's not. Okay? It's this angle congruent to this one, isn't it? Because those are the ones made by the sides that are not congruent to each other. So how on earth then are we going to find, I'll even call that 85 so we see it. How are we going to find that missing measure? They have to add up to 360. All 4 angles, right? It's a quadrilateral. And just like in a triangle, the sum of the angles is always 180. In a quadrilateral, it's always 360. So what is that missing angle? 70. All right. Questions? Wow, and I was afraid we weren't going to get to the homework. So on page 440, let's do 1 through 13, 16 through 21, 24 through 27, 37 through 49, 65, and 70 through 73.